Greetings, everyone. Yesterday, you had an opportunity to multiply and divide decimals working with concrete objects, base 10 blocks to be exact. Today, you will continue multiplying and dividing decimals, but you will be using pictorial representations. Let's get ready. All you need right now are your eyes, your ears, and your mind open to what we're about to learn today. Let's get ready. Here we are multiplying and dividing decimals using pictorial representations. Our learning target, and we actually have two. The learning target, we have the first one is I can use hundreds grids to find the product of two decimal numbers. The second learning target, using the chip model, I can determine the quotient of a decimal and a whole number. Here's our first problem. I've given you 2/10 times 4/10. Well, you have a hundredths grid. We're going to use that hundredths grid to shade in the representations of 2/10. So first we have 2/10. There are 10 rows going across, and there are 10 columns going up and down. If we shade in two of those columns, that's equal to 2/10. We're going to shade them up and down, which is vertically. Now we are looking at our 4/10. Well, this time we're going to shade 4/10 going horizontally. And as long as we shade in 4/10, it doesn't really matter if you shade in the ones starting at the bottom or the ones that are starting at the top. But today, I'm going to start at the bottom. So I'm going to shade in 4 rows of 10 in yellow. So because we're multiplying, it's 10 2/10 of 4/10. So we're looking at the portion that overlaps. Pink and red, excuse me, yellow and red. So if we're counting, each square is equal to 100. So we have 100, 200, 300, 400, 500, 600, 700, and 800. So 2/10 times 4/10 is equal to 800. I have gone back and struck out or drawn a line through each of those squares to show and represent 800. Now, if you notice our pictorial representation, we have 200 grids, not just one. I know you know the reason why we have 200 grids is because one of our numbers shows one whole. So what we're going to do this time is we're going to shade in one whole to represent that whole, and then we're going to shade in 7/10. But instead of starting off vertically, we're going to start off horizontally. So we're going to shade in this entire hundredths grid to show one whole. And then we're going to shade in 7 rows to show 7/10. So we will have one whole and 7/10. Here's what it looks like. Next, we have 5/10. But we're not only shading in the 5/10 of one of the pictorial representations because the number is 1 and 7/10. So we're going to have to shade in both of those representations because that's one whole number. Now 5/10 is also equivalent to 1/2. So we're going to shade in half of this whole. Then when we come over here, we're going to shade in, once again, half of the entire hundredths grid. But then we're going to go back and focus on what part overlaps in both of those representations. So let's show the shaded. And if we notice with our whole, the entire figure is shaded pink. Half of it is covered in pink and blue. So that representation is equal to 5/10. Or if we're counting each square, remember I said that each square represents 800. So that means that that is 50 hundredths. Well, if we come over here, again, we're looking at what's overlapping. So we're only paying attention to the portion that has pink and blue. Well, if I'm going across and I'm looking at the rows, I know that there are 5 squares in each row. 500s are in each row. And then so we have 500s. 500 makes 10 hundredths. 1500s, 2000s, 2500s, 3000s, 3500s. So we have 50 hundredths plus 3500s. Let's see what that equation looks like. So we have it written down at the bottom. 50 hundredths is equal to 35 hundredths. So all we have to do now is add those two numbers together. And when we add those two numbers together, we get 85 hundredths. Pretty simple, right? Lots of shading, I know. All right, so let's move on to division. Let's get a little practice with division before we get into doing it independently. Now, what we see here is a place value chart. And in our place value chart, we're going to use discs or dots or chips, all right? So what we're going to do first is just like we do when we're doing division, we take our whole, the number that we have in all. So the number that we have in all, our total is 5 and 241 thousandths. And we want to represent 5 and 241 thousandths on our place value chart. Here it is. This is what it looks like. So we have 5 ones, 2 tenths, 4 hundredths, 1,000. All right. If you notice here, you have 3 dotted lines or 3 sections or 3 divided parts. Well, we're dividing by 3. So we have to make sure that we are sharing in 3 divided parts. All right. So what we're going to do is we're going to look at the ones and we're going to see how many do we have in each part or each divided portion equally if we're sharing them. Remember, you have to share them equally. So if we share them equally, each row or each group gets 1. I want to make sure that I'm also connecting the algorithm because that is what you're going to see next. With the algorithm, the 1 represents in the quotient how many is in each group. The 3 in the algorithm represents the number that we were able to take away. The 2 in the algorithm represents how many are left over. So there were 2 that were left over that we were unable to share, all right? So those 2 will then be bundled and will be moved over to or renamed in the tenths place. So we have 1 bundle of 10 and another bundle of 10. So that means that we have 20 with 2 that are already there. So 20, 21, 22 in the tenths place. And that's where we got 22. That's now the whole that we're working with. So now we have 22 tenths that we're trying to divide equally into 3 groups. We're going to do it all at once. So what we did was we took groups of 3 though. It was color coded. So remember that. You can go back if you have color pencils or you have crayons at home and you'd like to be able to make sure you've used every single dot. So 3, that's the first group. The second group makes 6. The third group makes 9. We count by 3, right? The fourth group makes 12, 15, 18, 21. 1, 2, 3, 4, 5, 6, 7. 7 in each group. And 7 in 3 groups. 3 groups of 7. 3 groups of 7, 21. 21. Well, let's look up here. We do have 1 that's remaining. So let's see what the algorithm would look like. Here we are. Each group receives 7. 21 were taken away, which is how many we crossed off. And then we had 1 left over or 1 remaining. Exactly that. That 1 is then bundled and moved to the hundredths place, renamed in the hundredths place. So now we have 10 hundredths, 11, 12, 13, 14 hundredths that we will now work with as our new whole. There's the algorithm, just making the connection so you see, remember we said 14. Now, once again, we're having to divide equally, fair share, our 14 amongst the 3 groups that we have. This time we're going to count them in groups of 3 just to make sure. But we could do them like we did last time. We could color code them and cross them out. It just depends on which way works best for you. I wanted to make sure that I showed you both. 3 more, so 2 in each group of 3. 3 in each group of 3. 4 in each group of 3. So let's see. 4 in 3 groups. So 3, 6, 9, 12. And let's remember we have 14 in all, right? So if we use 12 from 14, we have 14, we took away 12. There's 2 left. We can't split, divide, share equally those 2 remaining dots. So the algorithm shows that we have 4 in each group, which is correct. We took away 12 from the 14, which is what we did, and we had 2 remaining. That is what we did. So now, of course, we have to take these 2 and bundle them once again. So each bundle is equivalent to 10. We're renaming them. So we have 2 bundles, which gives us 20 thousandths, plus the 1 that was already there gives us 21 thousandths. This is what it looks like. All right. So now we have 21 thousandths. Well, hey, we've used 21 as our total once before. Let's see. Remember, when you're dividing, you can go back and use that lollipop. You used the lollipop when we were working on converting decimals and fractions. Go back and use those strategies as you're dividing here as well. Please don't just throw those to the side. Utilize those just as a memorization for your facts, all right? So 7 will be in each group or on each row. And that would have been 21. 21 take away 21 should leave us with 0. Here's the representation. We were able to use 7 in 3 rows or on 3 rows. And that is correct. That's 21 total. There is 0 left. So if we look at our quotient is 1 in 747 sevenths. Excuse me. Wow, that did feel like it took a long time, but I hope that you actually understood how we were actually dividing with our algorithm. We explained how we got each number, how we fair shared as we equally made groups. Guess what? It is now your turn to try. So the practice set is listed below. You're just going to click on the link so that you have an opportunity to practice them. Pull out your colored pencils, your crayons, your markers, whatever you like to use. If you do not have those items, a pencil is absolutely fine. Take your time, do your best. Remember what we just did and that we took our time with our pictorial representations, and I know you got this. Take care. We meet again.